Apparently the red light at the front indicates that we are recording the lecture now. There was a problem with last week's one, it didn't auto record. But for anybody who's not here, that thing's just available. It'll be available, I think, tomorrow or the day after to sort of capture that. Two things I was going to cover today. One is the actual bit on the theory side. But first of all, I just wanted to give you a few demos of what some of these sort of commercial devices are for it. Now this is, as I say, just available. This is the commercial IoT nodes part to it. I'm just going to have a look at one or two nodes and pass these things around for you to have a look at. Show you how, compare with how what you're doing in the labs might end up if you package it up in a nice little white box type thing. These are sort of commercial things going out. The first one we're going to have a look at here, and again, sort of, I'll pass this round to be looking at. The first one is Honeywell Evo Home radiator controller. This can be retrofitted to your existing radiators. You don't even need to sort of empty the radiator and turn the water off and anything. You just replace the valve. And it's got a little motorised valve inside it to go up and down. So that's really like a bit like a servo motor. And then there's an LCD display, a little turning button on top to set the temperature you want, but it can be remotely set, and there's a temperature sensor inside for it. So it's a collection of sensors. It's got some communication associated with it. This is what it sort of looks like, a bit of sort of background info on it. Slightly updated model. I've just sort of hung on to one of my old ones here. So you can see what the temperature is, powered by batteries, a couple of AA batteries in the back. So it's a bit of a self-contained unit really there. I'll start that thing, just worry around if you just want to have a pause it, have a look at what it is. As I say, it replaces the existing valve, very easy to retrofit for this. A couple of AA batteries for it. It's got wireless communication using something called Z-Wave, which is a bit out on its own now. It's still quite a bit more on the engineering side of things. Most of these IoT devices have gone over to either Bluetooth or Zigbee. This uses this Z-Wave one. You'll see at the back behind that little screen what's called the hub of this, or the gateway part, and all these nodes, all these little radiator controllers connect centrally to that in a sort of like star network. So that centralised hub just communicates directly with them. You've got a central screen that you can just sort of have on your table, on your wall in your living room to control each one. And it can just be home controlled like that and just have it centralised for it. But it can connect to the internet as well. If you want an internet connection to it, you buy this separate gateway module that links on over. There's a lot of terms that we'll be talking about today that will be coming across in the lecture session this week and next week. It currently has no public API to it, so unless you're prepared to hack it, which many people have, and you'll find lots of online guides to that sort of thing. Information centres, little JSON strings flying backwards and forwards, and if you can intercept those and pass them on, then you can sort of write your own controller for it. But Honeywell haven't released a public API. They might release them to individual software developers, but nothing sort of public for it. Yeah, Star Network, app available. There's some sort of app shots of running it. When you're running it, you can connect to an individual screen, I've got the same diagram twice there, sorry. You can connect up to an individual room, set the temperature for that room, set the calendar sort of options for the room. And if you look at it over a sort of wider scale, how it sort of connects in with the net, you've got your centralised hub over there, talking out, as I say, in a star type network to it. That can be self-contained just locally, or you can get this internet connection connects through to your router. That's a wired connection over to your router. And using that, you can connect to Evohome's cloud server to access that sort of device. And then they provide you with this home app to connect through. And that home app bounces through the cloud server and then back out to your own device for it. So I've got a sort of demo of that in action. I think I may have tried to sort of do this last week. I'll swap that over to the document camera. Come on. So there's the idea of sort of being able to sort of work around it. You can select a particular room, set the temperature that you want it to be. So it's got a nice little sort of interface. When you select the temperature, you can just sort of drag it up to what you want that sort of room temperature to be, and sort of set it up for it. So the app's sort of quite good for it. But we have had a few people sort of, as I say, hack that sort of interface and try their own with it to work with. Other ones that are out there, that's the one I've shown you, giving an idea about how it connects to the sort of internet. Say no API available. When you come round to doing your sprinkler system for this assignment, it'll be something like that as a systems chart to produce, about showing what the different protocols are at different parts. Another type of one available is the Hue light bulb. That's one of the Hue light bulbs. Unfortunately, I'm not going to pass this one around. The last time I passed it around, it smashed some out. We've got like a broken one, and they cost some. These coloured ones cost about £40 a piece. And it's my own personal one, so a few tears to absorb that cost. I'm being a bit conservative and hanging on to it. But they come with a, again, they connect to a centralised hub to it, and you get multiple lights around your house. They can communicate with each other. This is an example of what we call a node, and we'll be going into more on nodes later on. And then we've got this sort of hub that they connect to, and this one connects to your router, to your internet connection. So I'll pass the hub sort of part round. As I say, the lights connect to that. These get the power. There's no batteries in this. The reason for that is got a whacking great electrical socket at the other side. You've screwed into the light socket, so it's getting its power from that for it. It communicates with that centralised hub, but a different type of network for it. It uses Zigbee as its communication. We'll be looking at these different communication protocols. Very similar to Bluetooth, but a bit faster to wake up as well. And also, they don't use what's called a star network. These have got the ability to communicate with other light bulbs. So whereas something like Bluetooth and Zigbee might have a range of about 50 metres, because the light bulbs can communicate with each other, they can hop out and go out sort of basically unlimited distance. So long as this can communicate with another one and then hop on to another one. So that's referred to as a mesh network. Hue are quite good at supplying an API. They're very keen on getting developers working with these. And they supply an API to use. It works just through URLs to connect over it. URLs that send JSON strings to control or turn off, turn on, set the colour of these sort of light bulbs. And again, they're just a sort of screenshot of the app. They allow grouping by room, so they've got a living room, and then when you go to the living room, you've got individual bulbs within it to control. And as you might expect from a light one, you've just got control over the light intensity, the colour of the light, which ones are sort of actually on, how you want to sort of group them together, that sort of thing. And again, you can get this sort of cloud app you get this cloud app that allows you to have the control over it. I'm not going to go into every app, just on the sort of live demo your app just allows you to group them together, turn them on, and again that works in this case either through the cloud server or if you've got your router, it'll connect direct through your router out to them. Business Developer API available, so you can write your own software for this, find out the format of the messages, send messages backwards and forwards in this sort of JSON format to work with. Those bulbs, let's say about £40 a piece for the coloured ones, but you can get cheaper ones for the white ones. If you just want plain white, you get those for sort of 15 to 20, I think. And there's lots of other manufacturers following on now for this. You get these sort of things like IKEA, sort of lots of other Chinese imports do it. These have been around for a long time. That's basic for it. Another little interesting one is the sensor box here. This is something that just sort of sits on your wall. This is an internal sensor box and records various sensor activity within the home to do with temperature, humidity, sound, air pressure, that sort of thing. Yeah, I'm going to sort of pass that around to have a look at. That's when you feel this, it's quite heavy, and the reason for that is that it uses Wi-Fi for its communication protocol. Wi-Fi is quite power hungry to it. Having said that, the batteries still last about 6 months in it because it's not continually streaming to Wi-Fi. It just records the temperature or the humidity, say, every minute. It's not doing it 1,000 times a second, it's not doing it every millisecond, it's just sort of sending these things out. So it's sending out, as I say, sort of temperature the sound sort of activity, and you can pick up on which room you've got one put in. The things with the red on there are just because I need the batteries changing in those. But in my daughter's bedroom and workroom that she uses, she's at home now, so I don't bother sort of maintaining the sensor in that one. I think this particular one should be sort of fairly live for it. This is the one in the kitchen there, so you can see some noise activity around about 4 o'clock. For it, sort of quite a bit of noise, and then it dies down towards 10:30, 11 o'clock, because we're all nicely behaved now. I was on a sad characters who go to bed around about 10, 11 o'clock, and so not much else is sort of going on. And a similar thing for the temperatures, that's sort of gone up through the day. You can use the sound as like a burglar alarm as well to detect movement activity going on inside. They do provide a public API to do with it, and you've obviously got this app. There's no hub needed for it. They just communicate directly through the router to sort of get in there. Another sort of external environmental monitoring one, a company called Netatmo. They do atmospheric monitoring. They also now moved into the home heating market to compete with the Evo Home. So if you go on Moodle and just look up Netatmo, you'll see radiator controllers similar to the Evo Home ones. These are things there, you can see, are a sort of rain gauge, a wind gauge, and then again a sort of centralised, there's a centralised hub, there's detectors for humidity, temperature. That's one of those. I've got it sellotaped up at the bottom because the connection came a bit loose. That's one of the Netatmo devices. But again, comes with an app to pick up on it, comes with a public API. The reason I keep mentioning these public APIs, it just means that you can tie it into your own code there. And as we move through the lab sessions, you'll start to be able to pick up some of these sorts of bits of info in your own code and then trigger off things in your own house. Because what we'll be looking at eventually is to have things like that perhaps sort of affecting your central heating or your blinds to raise up and down, or sort of open windows, that sort of thing. So we'll be wanting some sort of API to pick up on these. They work off a star network. The taller one there just communicates with everything within a certain range. So I think everything has to be within about 30 metres for it to sort of work on. We have got one of these kits available if anybody's doing a project involving some sort of outdoor sensing. We've got one of these available to put up perhaps in the quadrangle place to sort of get it from. And later on, I've got one of these sort of set up in my own house on an external weather station, and I'll provide some sort of public access to be able to sort of read that if anybody's interested in sort of working with it outside. The final one, just have a quick demo of, is something called the Amazon Dash button. There's loads of these things about. These are just a few sort of samples. These are almost free to get hold of. They've been promoting them for a few years now, and all it consists of is a button to it, and it's linked up to order whatever the advertisement's there for. So you click it, and it orders you finished dishwasher tablets, or you have one stuck to the wall next to the toilet there, to say, okay, to the desk work, click the button. It's not guaranteed to come around within 2 minutes and say, here's what you might need at that point. But the idea that they're trying to promote is that you just fix them around the house and have automated ordering. So they're trying to tie you into their ordering system. These ones have got just a single battery inside it, and it's sealed, which means that once it's done, it's done. You have to get another one, unfortunately, for it. Communication is using Wi-Fi, which you would think would eat up the battery power, but because you only click this once every few weeks or something like that, or even once a week, it's not using a lot of battery power to do that. There's a setup that just comes to allow you to link it up to your own sort of Wi-Fi in the house to sort of get it working with. There's no public API for it, but these things are hackable. For it, and we've had quite a few sort of people working with that. You can intercept the signal going out, and then because all it sends out is an on-off type thing, and just says that each one's got a unique ID, and it just says, well, this ID has just been clicked, so you can sort of basically hack it into being a button, a generic button controller. And that's actually, there's one of them coming round. I think it's a coffee button. And the other one's a more generic IoT button that has got an API to sort of program with. These things typically cost around £5 to buy. And also, when you order your first order of Tide or whatever, you get £5 off. So they're sort of effectively giving it away. But they're trying to tie you in to using that sort of Amazon buying for it. So it's just a few ideas, just as I say, so coming around to give you an idea of some of these sort of commercial ones. The ones with APIs are relatively straightforward for you as a coder to interact with. So you could either pick up the sensor information from it, or send information to it if you want to turn things on, that sort of thing. Other ones you'll often find, as I say, are hackable, whether it's this one or the Evo Home one. Just involves a bit more background work around that. So that's, as I say, just to give you an idea of some of the commercial ones. Other things just around. This is a diagram of an environmental sensor box that was created by one of our students. He called it a citizen sensor, built out of a Raspberry Pi, there at the bottom with a board on top to connect a few sensors to, and he wrapped up in a nice little plastic box. The idea was he was a keen cyclist, and you carry this about with you, and it would report as you're cycling around on the environmental conditions of where you are, both your speed as you're going along, what the pollution sort of levels were, whether it was raining, the heat of it, and other cyclists could pick up that information and sort of decide, well, I'm not going to go down Oxford Road at the moment, it's really polluted, I'll just take one of the sort of other ones. You know, a bit sort of like sort of Google Maps does, but for the sort of weather part to it. So he put a few sort of temperature ones on there. These weren't the Fiji ones there, either from Arduino or this company called Seed that he sort of got them from. Just wired them up to, but it's the same sort of basic idea. And then created an application that would broadcast this out to anybody who was interested. You'd have these sensors talking to sensors over at the left-hand side, this MQTT client, and they will publish temperature, noise, air quality, that sort of thing, out to something called an MQTT broker, and we're covering that next week about MQTT brokers. That's why it's sort of fairly relevant here. And what that does is it allows other users to subscribe to that broker and pick up on all this environmental data. So you could have an app at the other side, a mobile device, that picked up on all this sensor information in sort of real time. And perhaps, you know, I'm not suggesting people sort of driving along with the app up in front of them as they're cycling, but you might have some sort of haptic feedback where you can vibrate something to say, avoid this route, and have it sort of like a code session like that. So this diagram will be a bit more relevant next week when you were looking at MQTT for it and what it's sort of sending out. So I'll leave that just as a reference. But the data that it's sending out, each sort of sensor is sending out a lot of attributes. So far we've been looking at things like a slider sensor that have got a value. Now this is sending out a whole chunk of data, the data value, what data type it is, where they are, how accurate that sensor is, and what sort of sensor range it's got. So anybody picking that up will know sort of a bit about, well, what am I talking to there? How accurate is this data? And again, we'll look at these sorts of things about the attributes of sensors next week. But it's just something to link in with what we're doing in the labs this week, where you'll be taking your sensor information and you'll create a sensor data object. And that's the thing that will go around from the client to the server. And it'll mean you just representing your data as JSON to send over the net. That was just this particular one. I'm not saying that that's everybody's one, that's just the one that they have for this project. So all that is just the background to some of the labs that you'll be doing in upcoming weeks to sort of tie it together for it. Why we're using JSON in the lab, why we're using MQTT, how we might use these things to link in with these sort of commercial nodes. But to get on to the main part of today, the systems overview. This is just to sort of have a look at a node system overall, or an IoT system overall for these things. Looking at what we call cyber-physical systems and how they've evolved from what used to be known as sort of real-time systems, moved out of the engineering field into a more programmer-friendly, user-friendly sort of field, into this idea of smart devices. But how these things fit in with real-time systems. A bit of a nostalgia shot of, you've probably seen sort of plenty of pictures like this of early mainframe sort of machines back in the 60s. These sorts of things were things on the right-hand side with data storage devices back on tape for it. You'd have some sort of big sort of CPU and a workstation to be able to sort of get into sort of using that for it. And if you compare what's there with what's sort of around now for it. Again, going back to the 60s, Apollo 11, moon landing and all that sort of thing. Its command module had 64K of memory. Now, 64K is nothing, sort of now. When you compare it with what we've got sort of now, an iPhone, even one of the older iPhones now, a 5S, that works at 1.3 gigahertz. So that's 1.3 thousand megahertz. So 1300 megahertz, basically. 1300 megahertz against 0.043. So whatever that is, 100,000 times faster. Your iPhone, 100,000 times faster than the command module controlling this Apollo 11. And the speed at which it was working, well, the memory there as well, 64K of memory. 1 gigabyte of memory, which is a fairly small memory in a phone now. That's 1000K. So you've got 1,000 sort of K of, well, that's a megabyte, sorry, a million K for it. The difference in memory for it. Basically, what it's sort of coming down to, with the speed of these old sort of Cray ones in the 70s even, working at 2 gigaflops and iPhone working at 77 gigaflops. You've got more in your hand, basically, than could take you to the moon a bit before that controlled all that. And that was available for using in huge commercial organisations for dealing with. Nobody ever really had a Cray one to themselves. It was just sort of too, it cost sort of too much to work with. So things have changed a lot. The power needed there, 200 kilowatts of power. So that's your like proper sort of mains electricity going through it, whereas your phone's just working off that sort of battery to sort of do. And whereas they were sort of doing these things to sort of predict weather, sort of do earthquake calculations, whatever, send people to the moon, what are you doing with your phone now? Well, I'm watching YouTube videos of Big Brother or something like that. I'm doing my sort of communication with my friends on Twitter, Facebook, or whichever. We're wasting a lot of the power that these things are being put to it. And what we've got now is a lot more power in a lot more, lot smaller system. So you've got your, obviously you've got your phone there. It's a lot smaller system containing the equivalent of what was a Cray 1 sort of supercomputer back in its day. So it all sort of being shrunk down. Now a cyber physical system is something that's connecting the real and virtual world. The virtual world of the, if you like, the sort of internet behind it, the real world being all these sensors that we're picking up information from to sort of get there. And the thing that's come along in sort of the last 5-6 years or so is that these have become highly pervasive. They become embedded in everyday life, not just in your phone, but some of these devices going round. They're now controlling your heating, controlling your car, a lot of these things that I mentioned last week. And we've got a lot more decentralised. Decentralised, and there's all these processors dotted around that all need to communicate with each other. And that's one of the things that we're concentrating on in this first half of the module, is to get all these different nodes connected. Because currently, those things that are sort of being passed around, they all talk different languages, they've all got different protocols. And we need some sort of master protocol, if you like, to communicate with those. And a lot of work is being done in that, but we're working in a decentralised network. Moving from this old idea of a standalone embedded system, like an outdoor motion sensor light, sorts of things that many people have in the house. You've got the light there, you've got a little motion sensor underneath it, it detects a bit of motion and it turns the light on. Now that's a little self-contained embedded system for it. We've got no control over that. There's no API to sort of interact with it, to be able to turn the light on when you want. It's all sort of self-controlled. built by a team of engineers. We don't know what the programming language is that they've got to control inside it, whether or not there's any wireless communication, there probably isn't. Through to this central control system where you may have sort of alarm systems with movement detectors around the house, sort of detectors for doors opening, lights being turned on, whichever for it, and possibly sort of connection to the outside world. It may sort of look big, but it's still really just sort of a central, a single control device. It's not really accessible to the outside world. And what we're trying to do is get to this stage of this sort of Internet of Things and start to link them together. So lighting systems connected to alarm systems, connected to these home security systems, connected to heating systems, all of which potentially, all of which are sort of standalone, but we want to be able to get the things working together. And it is coming. We're sort of in that sort of stage of moving over onto the sort of Internet of Things. Similar things that these sort of driverless cars are trying to do. Having all these sensors to detect when things are inside range, so we've got sort of radar sensors, rain sensors to turn on your headlights and your wiper blades, that sort of thing, location sensors to be able to find your car when you've left it in a car park, or mapping sort of ideas to sort of work with. So we've got a lot of connected devices, but we've got often this human being in the loop, and that's the thing that's causing us a bit of problem, or not a problem. So some people want to eliminate this human being in the loop and just have everything sort of automated to it. But you get into that potential scenario that I mentioned last week, where you have your internet-connected fridge that's got access to your medical records that just decides, sorry mate, you're not allowed into this fridge today, you've already eaten enough. Something where it's sort of totally automated. If you take the human out of that loop, then that's the sort of situation that potentially you can sort of get from it. We're looking to connect all these components where we'll have a series of sensors generating or collecting this data, giving the outputs maybe to a human being through a phone device or through a screen, or maybe sort of feeding those outputs back into the inputs. Now, where it fits in with computing, in computing you've got a sort of whole series of fields to work in, and this sort of whole IoT is really sort of within computing multidisciplinary, in that it fits in with a whole sort of range of other topics, whether it's machine learning and artificial intelligence, to learn from activities that's gone on in the past, learn your activities, say, around the house. So it knows that, typically on a Tuesday, you may be sort of home around about 5 o'clock or something like that. So it detects movement around about 4 o'clock. That's a bit of an unusual activity, and perhaps just to send you a little text message saying there's some activity going on at your house. Similar things for heating controls. So we've got all sort of the whole machine learning, artificial intelligence sort of part into it there. HCI, or whatever it's sort of called now, something XP or whatever, human experience or something like that. I can't remember the new title that it says. But often these things are not particularly well designed in terms of the human interaction. And it's often a place where projects fall down. If you've got a project in this field, we often assume that other people know the same as we do, and that they're sort of computer background or something. You've got to realise that typically these things are going to be talking to certainly non-computer literate people. Imagine writing it for your, say, grandparents or something like that, so that they can understand exactly what's sort of going on. There's a lot of security aspect in here, and robotics and control systems. We're operating things around, background security of all your accounts for it, sensor networks, real-time systems. As I say, a lot of fields within computing to sort of tie them into. Sprouting out to all these things with smart in their titles. Smart energy, smart parking, smart homes. It's really the thing these days, just put the word smart in front of something. And people think, oh yeah, well, it must be something technical now. to it, or we must be sort of great for it. And what we're going to be looking at is, well, what actually is a smart thing? Well, we've got all these technologies that you can't do without, your phones and your smartwatches and things like that. We're talking about building, in general, a smart X, where X can be anything. It can be a phone, a watch, something that we're aware of, fridges, glasses, a smart wardrobe. So what would a smart wardrobe do, for example? I mean, if you're like me, obviously no fashion sense whatsoever, or something like that. I just wear whatever's on top of the pile when I come out in the sort of morning. But some people might want a bit of sort of advice on what's the best thing to wear that day, both according to what day it is. It might have access to your diary, know what's going on in your life, know what the weather's like outside, have access to current fashion trends, what's going on with what your friends are wearing. I mean, you know, God forbid that you walk out in the same shirt or blouse, whatever that somebody else is wearing at the same time. Nobody in here is wearing exactly the same. You've all got sort of different things. We all walk, if you suddenly sat down to somebody wearing exactly the same, you'd feel a bit uneasy to it. So you're talking, there about anything can become smart. It just does what it does a bit better, a bit of sort of intelligence built within it. So they've got to understand our need. They've got to be context aware. What's going on in their environment that's relevant to what they do. A wardrobe isn't necessarily interested in stocks and share prices, for example. It's not interested in whether or not you've done your assignments during that morning. Those sorts of things are relevant. Other things sort of are. So you've got to be context aware and have some sort of implicit human-computer interaction relevant to their sort of devices. And we're moving through again from these devices that have got communications built in them, like phones, computers and the like, through to powered objects that don't normally communicate, cars, home appliances. They are sort of powered things, but we don't think of them as communicators. And then standard objects that don't have a plug and don't communicate. Clothing, stationery, furniture. You don't think of those as having to power them or having to communicate. And the smart things are when we sort of start being able to connect these sorts of things together. So we do have, for example, our fashion faculty here. They're developing smart clothing that has got the ability to sort of conduct electricity built within the thing itself, so you can have sensors built within the clothing to detect things again sort of in that sort of outside area. Every sort of area is thinking about sort of what smart devices are nowadays can become part of this whole Internet of Things. A smart device is just a thing. It's just an object with some sort of sensor or actuator or tag that interacts with the outside world. So it can sense something in the outside world. So we've got a collection of sensors that you're using in the labs. But it might have an actuator. It might be, as I say, like a motor that's turning. Like the Evo Home sort of thing. That'll got sensors built within it and an actuator for the actual sort of device. It must have some processing power. So it's collecting this sort of data and deciding what to pass on. It's got to communicate it, so it's got communicating ability. But it's not just sending out streams of this data. You've got to decide which bits of data to send out and how often. And again, one of the things that you'll do in the lab this week is you've got to sort of decide when you're, say, moving a slider and sending that off to a server, how often do you communicate with the server? The sensor might be able to give you data every millisecond, thousands of times a second. But do you want to sort of send the temperature of the room 1,000 times a second to the server? You might want to just rein it in a bit and have some sort of processing power of deciding when to send that data, perhaps to send aggregate data, averages for the last sort of few minutes or whatever. So a smart device has typically got those sorts of capabilities built within. Might be multiple sensors, some sort of improved computer interaction. They'll have a variety of things that possibly might add within there. But generally, they're sort of fairly low powered. Again, a bit more sort of on this next week, but they're typically acting as a data collection point, some sort of human-computer interaction. As I say, maybe on that that valve controller showing the temperature of the room, a bit of data processing going on, a bit of sort of local storage going on. These sorts of things are normally happening inside this node device. So collecting, interacting, doing that bit of processing. Depends on how the processor actually is within that for it. So we've got these devices dotted all around your house. Smart energy, home lighting, your security systems, your home entertainment, those sorts of things. But as I say, they're all single domain ones, they only sort of talk to themselves, and we're after something that can perhaps link all these together. Plenty of cheap, smart devices about that, yeah, perhaps sort of work with an app and allow you to do that sort of control, but can it talk between the sort of two? So if you're, say, your security detects that something's going on outside, can it just lower your music? But it just sort of say, oh, you're sort of head banging away or something like that. You want your, hopefully, if it detects something, you want your music to go down and just actually be told about it. What's going on? So, you know, a bit of interaction between these devices, you know, these sort of different systems. So that's the thing that we're looking at building both practically in the sort of lab. So we'll sort of move over into take about 5 or 6 weeks just to get our whole sort of system together. About collecting this data and doing some processing and sort of sending it on. What we'll be doing, carrying on in this sort of theory section, is looking at, well, what should you be taking into account when you're actually putting these things together? If you've got to have to make a choice of communication, whether it's Bluetooth, Wi-Fi, Zigbee, Z-Wave, all these sorts of different ones, which ones should you use? What's the best sort of protocol to use? What are the operating systems that work in these devices? Certainly you won't find on that, say, that Evo Home thing going round, or that environmental box, you won't find that it's running Windows XP inside it, or Windows 10 or anything like that. You'll probably find it's either a really sliced down version of Linux, or operating systems that are devoted just to tiny devices. And in future weeks we'll look at things like Tiny OS, this tiny operating system built for Internet of Things devices and Contiki and other things like that. So these sessions are where we're looking at that sort of aspect of it. And the lab sessions are where you're actually sort of implementing. And will tend to come together in about sort of 4 or 5 weeks. Okay, we'll leave it there for today. If you can please bring back down the register of my little devices, leave them on the front here. We'll see you for that. I think you were talking about getting more separate cards and enabling to do that. Alright, so I'm going to bring you down the red card.
Those.
Hi, how are you?
I thought you went. No, I thought you went.
Cheers, 3 people waiting to start.
Water.
It's probably best just to make sure. I'm not sure whether make sure of it then.
No, I was just saying, like,
Well, it'll probably be called until sort of 10. Maybe. Well, yeah, we have problems on the right hand side.
No, I'm already. I'm literally just here waiting for Oh, right.
You can offer this side. Are you on my project? No.
Here's another one that you can walk about.
We're going to be on the end of the recording. Asking what's happening.
Who's your supervisor?
tapping it like.
Flashing red indicates error.
Sorry about this, Kiwi. I'm giving it out too early to pass around.
Didn't quite make its way around.
Well, I could say that you weren't actually in on time, maybe. You sort of arrived a few minutes later.
All the census got passed around.
He's like,
All the what?
It might be better if we do this back to
You know, cock up like some
well, if people wanted a printer.
your pen.
Are they just always like
And then I'll turn up to the lab. A little bit less sleep.
I'm seeing Raheel this afternoon. Again, I'm seeing Raheel again.
About that. I mean, there's not what you can do.
I know, but
We've started. You missed
well,
it.
no, but he's potentially like maybe at least next year, because next year it's going to be 10 to 12 and then 4 to 5 on the Monday.
Yeah, on the Monday.
That's
We don't
rush hour. Oh, could you sign me in?
Yes.
Just sign everyone in.
Yes.
Just the whole class. Yeah, I've said it.
Yeah, so that's what Chris told me. So 4 to 5 would be even worse, like leaving at 5.
If you get the train leaving at 5, it'll be fine. Not
You get in the train, but she drives.
I don't know.
I think they're hoping to get you lot these
Well,
cards,
I'm
aren't they,
getting
as
I'm
well?
literally
Yeah.
going to be getting a dog very
To sign
soon.
in.
So if I have to leave in the day, I need my car.
Thank you very much. See you later. Yeah.
Just drive up to Hazelgrove and walk to Hazelgrove. 25 minutes on the train.
Yeah.
Are you
Very
in
close
this
to that
afternoon
one.
as well?
Yeah. See you later.
Okay, we don't have Probably, you know. I mean, I'm presuming it's a
My timetable on Sundays. I was a cute baby in the UK. I was really bad. I want to go with you, but I don't. I was like, I did it. Yeah, she was like, why did you get some more? You got to go as well.
The best of both worlds. Check our home. Right, our home. So that the house. Has anybody said anything about Lady Gaga except for me?
No, I think I should. I don't have a number. I'm not on the board.
You think about who you are. I got pets. All of you?
Yeah, I'm 16.
Yeah, that's it.
I
I love the little stuff.
How do you do that to me?
Well, it's just-
Really? I need to start doing as well.
it's so good. This is
It's hard. I know a lot.
she always talks to that. She goes, oh no, you're like how.
You're such a liar. That's funny. So it's just like, I'm done part two before.
You give them power.
Part two is it's quite easy because they literally tell you. They might have part two now. The hardest one I find is digits. I don't even get that. I said that. Or this one. Or like application one. Yeah, I'll grab that.
Is that? So we've already got 1, 2, 3 in or something.
I was going to give it. What?
This digit thing. Have you got something to do in or what?
I don't know, but you have to do like certain labs and get the, you can get the, you know, those things that you do over again, you can get that from the office.
And then you have to give that in.
Yeah, you can borrow it, I was going to say.
You give it some time.
No, you feel very good actually, you feel like you're very, like I feel like I'm here, but I feel I'm with I have to look at my hands actually see if it's full perfect.
Idea, not bad. Especially with the electricity.
Yes.
So it's so hard.
My body will explore everyone. What's going on next? You swing the other way.
I think both of today.
I'm such a hell, guys, honestly. Alright, I'll see you later on. So, do you know the lamp now? I know it's yours, isn't it? You was yours Thursday night. When is our artificial intelligence? Lab? When is it on Friday? Thursday.